www.tamu.edu, and it goes, if it's an HTTP, it's going to, by default, not definition, but by default, that's going to be over port 80. All right? And what I'm going to do, so the destination is port 80 on the web server.
Based on?
Internet specs. So 53 is DNS, 22 is SSH, 80 is HTTP, NTP, oh, I don't know that one, which is the network time protocol. FTP is 21.
443 is for HTTPS.
Yeah, 443 is the secure one. And then you're going to have another layer which is SSL, but anyway. So there's this payload I want to move, and I keep piling extra stuff on top of the data structure in order to send it over the network. And then on the other end, I peel all those things back off and eventually get into the payload. So if you understand that conceptually about networking, that I've got to fill in all these parameters, and that there are these different standards upon which I find the information I need to use to fill in the parameters, it becomes a lot easier. Then I understand what DHCP is, because, well, I need to have an IP address, and I need to have the DNS. So DHCP gives me this, DHCP. And then in order to move to my HTTP, I need DNS. Right, so that I have the actual, so that I have the IP address.
So the DNS is a middleman between your...
These are more of what I would call processes. I don't know, there's probably a better name for them, but they're like things that I want to do. Then there's the actual packet structure. So DNS means I want to resolve a domain name.
Right, but first I send the entire packet out to the web, and the DNS returns me the, no?
So before I do HTTP, I have to have done a DNS.
So where do you get that information? So the DNS is just assigning.
So I'm starting with just this, right? And then, well, I'm actually starting. I can physically, I know I can start with this. In order to fill in IP, the first thing I have to do is DHCP. So there's actually DHCP packets and ARP. And so there's other protocols besides IP in order to get the IP addresses to fill those in. So I do a DHCP so that I can do IP and communications to another device. I do DNS so that I can produce HTTP requests.
The DHCP is handled locally, or that's handled by?
It's by a router.
Okay, so hardware.
Now on the Beagle, by default, it includes a DHCP server. So the reason when I plug it in, it gets the magic IP address is because anytime, but the default for most operating systems is when you would connect a network adapter to it, it will try to do a DHCP on that network adapter to send broadcast packets and try to get back an IP configuration. You can choose not to do DHCP, and you can do simply static IP definitions, right? And that's where you go into your configuration tool, and you can say, this is my hard-coded IP address, this is my hard-coded router address, this is my mask, these are my DNS servers. There's all these different parameters. Or you could just select the magic box that says use DHCP, which is the default. And you hook into it, plug in the network cable to the LAN, and that stuff just automatically gets fed out to your computer.
You ask for it from the server, or from the router.
From the router. So this, like by default on the Beaglebone, we have a DHCP server running on it, right? That's not for it's connecting to the regular wireless LAN. That's for when it's serving this USB network. Question.
So if you want to connect two together, could you turn off the DHCP for one of them so that they'd be on the same
You
network?
can statically configure the networks if you want to do something as crazy as that. That's probably not the easiest way to do it. The easiest way to get two of them talking to each other is to put them both on the same Wi-Fi network, in which case the router that they both connect to serves up IHP addresses to both of them. There's another really cool protocol that doesn't have, so DNS relies on a central server. There's a thing called MDNS or Avahi, or what's the other name for it? Depending, Bonjour. So I think that one's the most generic. This is a Linux name, this is a Mac name, but it's a way for devices to broadcast services on an IP network that they offer up. By default, the Beagles will advertise services over Avahi, so two Beagles can discover each other if they're put on the same LAN. They can automatically find each other. So that's the way to do it, rather than static IP addresses. Just connect to a router that has DHCP, broadcast. By default, they're already broadcasting themselves. You just need to start listening for it so you can find the other Beagles on the network. Question this way?
Yeah, I thought it might just be good to mention the difference between UDP and TCP.
Yeah, so the big difference between UDP and TCP is that TCP, if there's an error, because it does a CRC check, so basically that's just a way to verify that the bits are most likely to have not been damaged, it will automatically retry. So for something like HTTP, where I want to get an accurate representation of a page and I'll wait for it in order for it to be accurate, you want to use TCP. So HTTP always uses TCP. UDP packets, though, are very much about, well, it's less important that it be accurate and more important that it that I get it when it gets sent. So it's UDP just is more raw. So if I do UDP, it still handles the kind of source and destination port stuff, which I should probably do a little bit more explaining of. But you just get the packet. It may or may not be somewhat corrupted or anything like that, but there's no retry. There's probably still you think UDP still includes a CRC
I don't think it does.
at all?
Like, whatever
You could
get,
potentially put a CRC in your payload to try to do your own error checking, but essentially you get the packet. So something like video streaming, if I get bad video data, it's like, well, I get some noise in the signal. But the worst thing is like it just waiting until I get the right packet. By now, it's a minute later, and like I really don't want to hear what you said a minute ago, even if it is just right. I just want to hear what you're saying right now. So UDP is a way of is networking way to do that. UDP just gives, like, if I don't get it, it just gets lost, and it doesn't try to retry it. Question there. So sockets. So we mentioned a bunch of magic ports, like port 80, port 22. You start doing networking stuff, you'll start memorizing, a number of these. The thing that happens is, like, when I go and open a connection, this is something that like a NAT would really handle. So I go and I create a connection. Like I get the response that's going to essentially, I don't remember exact mechanics of this, but it's essentially open up a new port. Like not everybody keeps going back to the same port 80 on the web server, right? It's essentially going to get moved up to another port so that you have that continuous communication. And like that's essentially a like where you get something like concept of a session or something like that. But you get a connection between the two, and you'll get ports assigned. That's how the NAT can give information back to you.
The net
a network address translator, your router that sits in the middle, because your IP address is no longer unique. So when the web server replies back, it gets a packet that's destined for your computer, but like maybe two computers on the network are both accessing www.tamu.edu. Well, how do I know which one to send where? So when I establish the connection, a port got assigned, and I just remember on this port I send it to this IP address, on this port I send it to this IP address. So that NAT, they both come back to the NAT's IP address because it actually replaces the IP address on the outgoing packets, so the responses come back to it. But it remembers that, okay, if the response is coming back to this port, I'm going to send it off to this guy on my own network, or this other guy if it's coming back on a different port. That was my deep dive into networking. It's just useful when things kind of go wrong to kind of understand IP addresses come from there, names come from here. There's other cool stuff that we can use to make established connections. I think we'll practically do this one, as well as kind of seeing how to get on a LAN. So I think we can do that interactively. Is that enough theory? Yep. Not really theory.
Away.
So on the Beagle, we don't have a nice GUI tool working over this this network connection to go and configure the Wi-Fi. The command line tool we use is Conman CTL. There are some some GUIs written to work over web browsers and other stuff like that. It's just nothing that we found that works reliably enough to kind of promote. So we're just back on command line. So within Conman, let me save off in the notes, by the way, at least. So I'm trying to put that all in the notes. Oh, what am I doing? Okay. So this is my Beagle, what it sees as far as available networks. I don't know if any of these are really great for connecting to. Is this I can set up my phone as a hotspot. Is there? Can we all use your hotspot, or is there a?
I think up to 8 or something.
Is that okay? Sure. Agent on allows me to save session keys, so I have to turn the agent on in order for it to actually connect to a secure network.
Sure, being cloud
How do I get there?
CD //.
It wasn't showing when I did LS.
CD space lib. CD.
How come it didn't show me the VAR folder?
Because you might have been in a different.
I'm going to keep going
I was in the top part of the sentence.
because I don't at this point I don't know what your question is, so I'm going to keep going.
No, that's fine. I was just getting to where you are.
We didn't quite understand what we meant by save session keys. So, like, when your agent on is
Agent. So if I'm going to connect to a network with a pre-shared key, so like something using WPA or WPA2 for a pre-shared key, I need to turn agent on so that I can do this. It's asking me the passphrase. And agent on will actually allow it to use the to remember that key and actually log onto that network.
Okay.
Remember the password, basically.
Okay.
'Cause I think it's
Creating a
more like-
secure session. Otherwise, if I just do a connect alone, you can't connect to a secure network without the agent on. I don't know why it's not the default, but I think otherwise it's not. Without turning agent on, it's not going to create persistent any persistent changes to the network configuration.
Okay. Because in my experience, whenever you turn, you can't continue to connect without turning agent on, like at all.
Not secure networks for sure. Insecure networks, I believe you should be able to connect to, but then when you power cycle, it won't do it again.
Okay. I haven't ever encountered that situation, so I probably